On our call today to learn about precision machine shaft alignment. My name is Jason Tilgis from Transcat, and I'll be your moderator today. With me on the call is John Burnett, Application Specialist for Vibration and Alignment Products at Fluke. John served in the U.S. Navy for 12 years, where he operated and maintained nuclear power plants. He then worked at Azima DLI for 18 years, where he developed reliability programs on ships and commercial plants in all industries around the world. For the past 3 years, he has been the application specialist for vibration and alignment products. He is certified as a Category 2 vibration analyst and is a certified maintenance reliability professional. John's presentation today will touch on many of the hidden costs of machine shaft misalignment, as well as how laser technology and other recent technique improvements have made this process easier than ever. Today we will spend the first part of our time in presentation, and we will end the call answering your questions. During any time, you can send questions through the question box to the right of your webinar controls. I also want to mention that this webinar is being recorded. Each of you will receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn it over to John.
Thank you, Jason. So for today, we're going to be talking about precision laser shaft alignment, and specifically, we'll be talking about the Fluke 830 laser alignment tool. So for the next 45 minutes or so, we're going to start off with some of the benefits first. Why is precision alignment needed? We'll talk a little bit about the benefits of both proactive maintenance and shaft alignment. We'll touch on the principles of alignment and laser, a little bit about what is laser alignment, what is shaft alignment, at least so you have a general idea. Then we'll talk a little bit about laser shaft alignment and how it's used, and we'll use the example of the Fluke alignment tool. We'll talk about the hardware, and then we'll go through the steps of an alignment job, and it's pretty straightforward, and we'll go through that and show you how that's done, and then we'll wrap it up with some other things like soft foot and things to look for and how to print a report. We'll finish up with what to look for in a shaft alignment tool. So we'll go through some of the, what are the features, things that bring out a good laser shaft alignment tool, and then we'll wrap it up with questions and answers. So let's first kind of set the stage of why do we use laser shaft alignment, and what is the purpose? It fits into a niche because to keep our plants up and running and keep our machines going, it often takes more than just one tool. If all we had was one tool, we wouldn't be able to finish our job. So here you can see how, if you look at the process of finding and fixing problems with machines, we would start off over at the beginning where a problem is found, and a problem could be found by some type of a screening device like a thermal imager that sees a hot spot, or a vibration meter down at the bottom that you can see found high vibration. So you'll notice that you see high temperature and high vibration. We would then call in a vibration tester to identify that fault. We know we've got a problem, we don't know what it is yet, and so the vibration tester would take some tests and would tell us that we have some serious misalignment, and the recommendation would be to align the machine. So then we would need an alignment tool. So we found a problem, we've identified it, we now need to fix it. So that's what we're going to talk about today, is how to correct the problem. So we'll talk about this shaft alignment tool that corrects the problem that is found. And then the last step would be, after our alignment, we would want to check it before we put this machine back in service, and we would use a vibration tester or a vibration meter. And you notice that now the vibration tester says no faults found, and the vibration meter says that it's the vibration levels are good when earlier they were unacceptable. So this is the type of process we would use to find, fix, and correct a problem. So I'm not going to go through every one of these benefits of proactive maintenance, but you can see there are some benefits to precision alignment, balancing, and correcting our machines and keep them running. It, number one, gives our maintenance staff time to schedule repairs, revenue, fewer unexpected serious failures, means that we're making product more, we're making more money. If our machines are running, then we're not going to have as much maintenance cost. Reliability, we don't want to have machines tripping offline. So these are the kind of some of the main benefits of why we do predictive maintenance or proactive maintenance, because running a machine till it fails is just not something that makes sense in today's economy or environment. Specifically to shaft alignment, along with some of the things we've already mentioned, one of the big factors of precision shaft alignment, of why we should do it, is energy consumption. It's been proven that if we have precision aligned machines and precision balanced machines, they run much smoother, they draw less energy, and anytime we can save some energy is a good thing. The next big thing specifically to laser alignment is fewer failure of seals, couplings, and bearings. A lot of times if we just leave a machine that's even moderately misaligned and still running and everything seems to be fine, we find that our bearings and our seals and our couplings are wearing at an advanced rate, which means the machine is failing. And other things like cracks and failures and bolts and vibration levels, all of these mean that we've got machines that are failing sooner and causing problems in our plant. So if we look at some of the benefits, here's some examples that other customers in the market have found over the years. We talked a little bit about the power consumption. One customer found that by using precision alignment, they were able to eliminate the energy consumption by up to 10% on their machines. Longer machine life. If we do precision alignment, then we won't have our bearings go. And mechanical seals, here we see an example. Mechanical seal repairs declined by 65% when precision alignment was carried out. Pump repairs declined by 30%. So there's a lot of different studies and a lot of different case studies done by customers over the years, and all of them have shown that precision alignment easily pays for itself. And when you think about the big problems with rotating machinery, the big two would be imbalance and misalignment. Misalignment would be probably a little higher than imbalance, and another problem would be bearings, and they're a little bit of a combination because your bearings and your misalignment both lead to your imbalance and misalignment both lead to bad bearings and bad seals. So when we look at some of the uses and applications, it's pretty much all industries and all applications. So if you think about precision alignment, it's anywhere where we have rotating machinery, in oil and gas, power, marine, steel, facilities, anywhere where we have a need to keep machinery running, we need alignment. So let's look a little bit into the technology and the principles of alignment and laser shaft alignment. So the first thing, what is shaft alignment? And it's if you look at the definition, it's the point of power transfer from one shaft to another where the axes of rotation of both shafts are collinear when the machine is running under normal operating conditions. So by definition, the point of transfer would be at the center of the couplings, and you can see that really what this is all about is if we have the two shafts parallel and collinear to each other, then we're going to have less reactionary forces. We're going to have less noise. We're going to have less vibration, less forces, and our machines are going to run smoother. So that's really our goal. Now let's talk about what misalignment is and how we can fix it. When we talk about the point of transfer between the two shafts at the coupling center, there's really four alignment parameters that we're looking at. There's four different degrees of movement. So the two shafts could be vertically. There could be an angle between in the vertical direction. There could be an offset between the two shafts vertically. There could be an offset horizontally, and there could be an angle horizontal. So when we look at our motor pump or motor fan, whatever we're aligning across the coupling, the alignment values are all done at the coupling center, and they're going to be expressed in these four different values. So we're looking at four different parameters. On this next slide, we look at it a little deeper, but still it boils down to the same thing. Alignment's a combination of angularity and offset, and we need to correct in both vertical and horizontal planes. So our alignment values are going to be a combination of these four numbers. Down at the bottom of the page, you can see where we represent these same four with the angle and the offset. So a lot of people ask right off the bat, and we see this quote quite a bit, why bother to align machines if they're fitted with flexible couplings that are designed to take up misalignment? I hear that question all the time. And it's true that flexible couplings are designed to take up some misalignment, but the loads that are imposed on the shafts because of that misalignment is still going to be felt, and those forces are going to be moved down to the bearings and the seals. So even though the flexible coupling will move and it will flex and allow for some of the misalignment, that still doesn't mean those forces aren't going to get to our bearings and our seals. So our choices are we either fix the misalignment or we continue to replace bearings and seals. So here's some symptoms of misalignment. We've already talked a little bit about these, high temperatures, loose foundation bolts, the couplings. So, if your bearings are wearing out, if your seals are wearing out, if you're having leaky seals, if you're having bearing noise, if you're having pieces of couplings, all of those are indications that you have some misalignment. Sometimes you can have some misalignment and the only thing that you know is happening is your bearings or your seals are wearing faster. So sometimes it's not an outward indication. Sometimes we're just using up a lot of energy that is wasted, and if we aligned our machines, then we would save a lot of money in electricity. So here's just a real quick pie chart of some of the consequences of misalignment. You can see that the biggest ones are going to be the machine vibration, which could lead to other faults with a machine. Bearing damage and seal wear are probably our biggest ones, because even though we have a flexible coupling, our bearings and our seals are being damaged and wear fast, and that means machines are failing because the bearings and seals are going. So we talked a little bit about, why do we want to worry about misalignment, why we need to fix it, what the problems are. Let's talk a little bit about ways that we've used to align machines. So there are, here's some examples of some methods. We have the straight edge or feeler gauge, we have the dial indicator, and then the laser alignment. And so let's talk briefly about these so you can kind of get an idea of what they're all about. So the straight edge and feeler gauge is really just, you put a ruler across the top of the coupling and you just eyeball it. The problem is it's not very accurate, and really what you're doing is you're checking the straightness of your coupling. So if your coupling is not flat or different sizes, it's not going to work very well. A lot of people feel if they just eyeball it, then it's going to be close enough. Well, close enough could mean that we still have a lot of energy lost. We have a lot of bearings and seals go, so not quite good enough. Another way of aligning machines would be dial indicators. Dial indicators are prone with errors, and it means that we need to have somebody with a lot of experience. There's a lot of mechanical play. There's a lot of calculations. It requires a highly expert experienced person to do this, and it takes a lot of time, because if it's prone to errors because of bracket sag and jumping dial hands and reading errors and tilt and axial play, that means that our experienced alignment expert has to spend a lot of time to correct for these problems, and sometimes have to do things 2 or 3 times to make sure the numbers come out right. So the problem with this is it takes an expert who and it also means that you're probably only going to do your most critical machines. So in order to be able to make this easy enough so that we can do it for all of our machines, then that's when laser alignment comes into to play. So laser alignment, you can see the resolution is very, very good. Lasers are very accurate. There is no bracket sag. There is no human error for reading dials. It's very accurate. There's no misrepresentation. You can document results. So the real big picture look at laser alignment is it finally allows us to be able to do alignment without having to be an experienced alignment expert, and so that a technician with a laser alignment tool can easily do a job in much less time, and be confident that they can do a good alignment job, which means now we can do many more machines in our plant and save energy savings on not just the critical machines but all of our machines. So let's talk a little bit about the parts and pieces, the hardware. So we're going to talk about the hardware, and then we're going to go through the steps of the laser alignment. So when we talk about the hardware, there's really 3 main pieces. The first piece would be the alignment tool, and we'll get to the alignment tool in a minute. On the shaft, we're going to mount 2 brackets, and these 2 brackets are going to hold 2 pieces of hardware. One piece of hardware is going to be the sensor and the laser, and the other piece of hardware is going to be a prism. And so the laser and the sensor are going to communicate with the alignment tool via Bluetooth. So what the job does is we put this equipment on our machine, and then we're going to rotate this laser apparatus brackets and take different readings so that we can measure whether the shaft is collinear, if they're aligned with each other, and then to find out if they're not, how much they're off. So when you look at the laser sensor, it's in one unit. Here we can see an example of the laser sensor unit, and basically it does two jobs. One is it sends out a laser. The laser then would reflect off of the prism and would come back into that same unit and the sensor. Down at the bottom left, you see a picture of the sensor. So as we rotate the shaft, the laser dot that is reflected back and onto the sensor is going to move, and the amount of movement is going to be calculated on the sensor screen, and that will tell us how much our shafts have moved in relation to each other. The prism is nothing more than a mirror, It's a specially designed 90-degree roof prism, and the purpose of the prism is to accurately reflect the laser beam back to the sensor. Now, there are some laser alignments that have equipment that have 2 lasers and 2 sensors, but having just one laser sensor and a prism means there's a lot less hardware, and it's a lot easier to get a job in a short amount of time, and it's more accurate. So the laser sensor prism principle that I've been talking about. So here you can see again, on the left is the laser. The laser would send out a laser beam, which then goes across the coupling to the prism. The prism reflects that beam back, and it goes back into the eye of the laser, and the sensor is inside there as well. So by using just one laser and one sensor and the prism, we're able to do the job with less hardware. Now, there's also a built-in inclinometer, which means that as we rotate the shaft and the laser sensor head rotates around, we know exactly where that laser and sensor are in relationship to the top, side, or bottom of the shaft. And here are some examples. I'm not going to get too deep into the principle, but you know, you can see over on the right that as we rotate the shaft around, and if we were to take 4 measurements, one at the top, one at the bottom, one on the left, and one on the right, we would get 4 laser dots on the sensor, and by doing the calculation on that ellipse, we would be able to calculate the angular offset, the vertical offset, the vertical angularity, and the horizontal angularity. So that's the process using the laser, the prism, and the sensor, is so that we can then calculate the values of the misalignment at the coupling center. So let's do a quick run through of a laser job to show you the parts and pieces. So the steps of a precision alignment, we're going to go through these steps. The first steps is to mount the brackets to prepare, and so here you can see a picture on the left of a typical motor coupled pump, and it's been tagged out and ready to go for us to do alignment. You see the alignment tool there in the case, and you'll see the alignment tool in the center. You see the prism on the brackets on the left. Sorry, not the prism. You'll see the laser sensor on the brackets on the left and the prism on the right. So we'll talk about the preparation first. Then we're going to walk through the 3 steps: set up, measure, and diagnose. And then finally, how to make the corrections to fix the misalignment. So we show here a quick reference guide because the goal of the tool is to make the job quick, easy, and not have to be a alignment expert to be able to do the job. So you'll notice that this quick reference guide is so that you don't have to relearn laser alignment. It might have been 2 or 3 months since you did it last time. So you pick up the card, and the tool will quickly walk you through the buttons of the alignment tool, the preparation of mounting the brackets, and then over on the right would be to do the setup, where we measure the dimensions of the machine. On the back of the quick reference guide, we would take our measurements. In the middle of the page, it would diagnose, tell us the problem with the alignment, and then how to fix it. So we'll go through those steps. I just wanted to show you this quick reference guide that makes it easy to not have to go through and read the manual every time. So we've mentioned these 3 steps. The alignment tool is designed to be very easy to use and take the user through step by step. So as you finish one step, it automatically advances to the next step, and then when you get all done, you have the answer. So we're going to go through these 3 steps: the setup, the measure, and the diagnose. So Before we do our setup, we need to prepare the machine. And the first step of preparing the machine would be to, of course, shut down the machine, tag it out, lock it out, and make sure it's ready to go. After the machine is all tagged out and locked out and ready to go, then we're going to mount the bracket assemblies on the machine. Notice from our earlier picture that we showed that the laser sensor is mounted on the bracket all together. You don't have to put the pieces together, but at the bottom of the page you can see that if you do need to take the pieces apart, you can. But you'll notice that you simply put the bracket assembly on the left side of the shaft. You run the chain underneath the shaft up through the other bracket and then lay it down and then tighten the thumb screw. You would then do the same thing to the prism assembly on the right side of the screen. So you simply pull them out of the Transcat case, put them on, tighten them down, get them locked on good and tight, and that way, and then from then on we wouldn't touch the brackets. We turn the shaft without using the, we don't want to move the laser. So we would then, so we would mount the wireless module on the left side of the machine. We do that by convention. If we need to, we can change that around. And we put the sensor laser as low as possible, but high enough for the beam to clear the coupling. Now, this model would have a wireless module that would communicate without using cables back to the alignment tool. And so you can see down in the bottom left, or sorry, bottom right images, you can see how the wireless module sits on the bottom of the bracket, then the laser sensor sits on top of it, and then that communicates back to your alignment tool. Next, we would mount the prism on the right side of the machine, and we would turn on the laser, and we would take the protective cover off the laser. The laser beam would then strike the cap of the prism. We would adjust the prism up and down so that the laser beam would be in the center of the crosshair as kind of a getting it prepared. After we get the laser and prism and the brackets all set up, now we're ready to begin our job. Our first part of the job would be to set up the machine. And to set up the machine, the alignment tool would walk us through the job where we would use a tape measure, and we need to measure the distances between the sensor to the prism, the sensor to the center of the coupling diameter, the RPM of the machine, the center of the coupling to the front feet of the motor, and then the front feet to the back feet of the motor. Because the purpose of why we're doing this is we're going to calculate the misalignment values at the coupling center, but we want to know how we can make adjustments to the feet of the motor, because that's how the corrections are done. We're not going to move the pump or the fan. The pump or the fan are stationary, but we need to move the feet of the motor up and down or left and right so as to put the motor shaft in alignment with the pump shaft. So these measurements, we simply take a tape measure, we measure these dimensions, and then enter them into the screen of the alignment tool, and then when we get done, we press enter, and it automatically advances to the next step. So pretty straightforward, pretty easy to do. The step 2 would be the measure step, and in the measure step it would automatically advance to measure. In this step we would adjust the prism. So we've got the prism, the laser dot, into the crosshair on the protective cover. We now take the cover off, and after we take the cover off, now the laser beam is reflected back into the sensor, and it would show up on the screen. So on our screen, we would see a couple of things. Number one, we would see the laser dots. On the left side of the screen, you'll notice that it says laser is ready. That means that the laser is being reflected by the prism back into the sensor, and the laser dot is inside our sensor screen. We would take a measurement at the top and notice that the sector would turn orange after we've taken a measurement. We then rotate the shaft to a 3 o'clock position. Notice the sector turns green, and remember, it knows that we've moved the laser sensor because of the electronic inclinometer, so it automatically knows that now we're on the side. And this the measurement takes a second or two. So we simply take a measurement at the top, rotate it to like the 3 o'clock position, take another measurement, it would turn orange. We would then move it to another position and take a third measurement. So we would like to do 180 degrees, but if that's not possible on a machine, we only need to do 3 out of the 8 sectors to make a complete measurement. After we make our last measurement, it automatically advances to the Diagnose screen. In the Diagnose screen, notice that there are several pieces of information here. Notice that we have the gap and offset, both vertical and horizontal. That is the alignment values at the coupling center. We also have severity values. Because we entered the RPM, we have tolerance tables built in the alignment tool that would then tell us whether our alignment is grossly misaligned or bad misalignment or just a little misalignment. But most importantly, over on the right are the adjustment values, because we don't just want to know how bad it is or how big these numbers are. We want to know how to fix it. And those numbers over on the right would tell you how much to move the feet up and down and left to right to fix this misalignment. So again, here's what I was talking about. It kind of blows it up in a little easier screen for you to understand. So the 3 pieces of information are the misalignment values, A, B, C, and D, and those are the actual misalignment numbers at the coupling center. The alignment condition, that tells us whether it's grossly misaligned or it's an excellent tolerance. And then the third part of the information is how do we make our movements. We put in shims to correct the vertical misalignment, and we move the machine left or right, and notice that here's a showing a hammer with an X through it. We don't use hammers to move our machines because that breaks machines. So how do we fix this? Well, we do it simply by we loosen the bolts of the motor, we jack the motor up, we put some shims in, and notice that the alignment tool is going to tell us how much to put in there. Negative feet correction values indicate we need to remove shims. Positive foot correction values tell us we need to add shims. Notice there's arrows that say we need to raise this machine up. After we get done with the vertical alignment, then we're going to go ahead and tighten the bolts up, and then we're going to go to a horizontal live move to fix the horizontal. In the horizontal live move, we're going to be told to put the laser sensor into one of the 45-degree directions. We're going to go to a horizontal live screen, and then over here on the bottom right, you can see what the horizontal live screen looks like. Notice that it tells us how much we need to move the machine left or right. We're looking from the top. You notice the arrows are telling us. The nice thing is because this is live, we simply move the machine live and we can watch the machine move. The values will change, and more importantly, the tolerance will go from red to orange to yellow to green. Then once we get all done, we tighten the bolts up and we remeasure the machine. So the final check is, after we've made the correction, we want to do a recheck to make sure we did it right. When we get all done, we save the data and then we print off a report. When we get all done and the report is done so that we can document our work, then we're going to turn the alignment tool off. We're going to remove the components and store them in the case. So what if we find that our alignment job didn't work, that we don't have good results? Well, here's a couple things we can check. One is soft foot. Soft foot happens when, due to corrosion or due to the assumption is that our machine foundation is flat. Well, what if it isn't flat? You know, what if you've got a bolt that's cracked or something that is wrong? So you know, a soft foot check is something we can do to find out if there's a problem. So built into the alignment tool is a check, because if we're having problems with our alignment, or maybe even before we start an alignment, a lot of companies do a soft foot check before they do an alignment. So here you can see where we have a process where we can loosen each one of the bolts one at a time, and the alignment tool will check to see if there's any built-in stress, which could give us a soft foot condition. Tolerance tables, we've already talked about these a little bit. So you would enter in the RPM of your machine, and then we would have some industry standards on what is acceptable for certain speeds of machines, and that way we could do our alignment, because there's nothing worse than not knowing when it's good enough. So by using these tolerance tables, we know when the alignment is good enough that we can start our alignment. We also want to be able to save our measurements. We save our measurements so that next time we have these values stored. And then, very importantly, is a report, because we want to prove that we fixed this machine and that we have put it back into a healthy condition. So we would print our report off to a PDF, and then we could use that as a documentation, and this would have all the setup values. It would have the correction values. It would also have any soft foot or any of the tests that were taken. And so this final report could be saved in a PDF. It could be emailed to a manager or a planner. Okay, what to look for in a laser alignment tool. So we've talked about a few things. The single laser beam allows us to have less hardware, and means there's less air, which means it's more accurate. We always want to look for something that's very rugged, ergonomic, and robust. Repeatability matters. So with the single laser and precision manufactured bracket assemblies, we're going to be able to get very good repeatability. Wireless is also something that's very nice to have, because if we have cables all over the place, then that means that it's going to take us longer to have to route cables around. And then having rechargeable battery packs that last for hours and hours means that we don't have to worry about finding batteries for our job. User interface, simple to use and not have to be an expert, is probably one of the key points to any laser alignment job. So if the job is easy to use, it saves you time, which saves money. You don't have time to relearn this all over again. So the Fluke 830 has been designed to walk the user through step by step. When you turn the device on, it automatically comes up in a the setup. When it automatically prompts you to enter the next dimension. When you get done, it automatically advances you to the measurement, advances you through the measurement 3 steps. When you get done, it walks you to diagnose. It gives you the answers and steps you through step by step, so you don't have to relearn the job every time. It has a built-in live mode, and more importantly, it provides answers, not just data. Just knowing the misalignment values doesn't do a thing. What I need to know is, how much do I need to move the feet up and down to be able to get this job, because I've got someone yelling at me and I need to hurry up and get this machine back online as quick as possible. So the all-in-one screen is very important, because it gives you all the answers in an easy layout so you can get the job done quickly. Other things, we talked about the machine tolerance check, extend mode. That's basically if you got a very large misalignment, or if you have a large machine, then you'll be able to do that with this job as well. Okay, and so to final wrap this up, the Fluke 830 is going to be able to do alignment of horizontal and vertical machines. We're going to be able to also align uncoupled or non-rotatable machines. It has a single beam for quick adjustments. The workflow is automatic. It walks you through, so you don't have to pull out a manual. It has electronic inclinometer so that you don't have to guess where the sensor is on the shaft. It has color scale to tell you the evaluation. It also checks for soft foot. It works for horizontal and vertical machines. It has extend rig. So I think we've talked about most of these. I think I've gone through most of the things that I need to cover, so I think I'll turn it back over to Jason to see if we have any questions.
Yeah, thanks, John. Real nice job. Appreciate you doing that for us. This concludes our presentation portion of the webinar. I'm going to get into Q&A momentarily, but before we do, I just want to let everybody know that Fluke is still running a great promotion that many of our customers have already taken advantage of. Now through December 31st, 2014, if you were to spend at least $250 on any Fluke tools, you would be eligible to choose a free gift. It's a staggered gift with purchase promotion, so the more money you spend on Fluke tools, the higher value the gifts you might get. So down in the lower end, you can choose from things like meter cases or IR thermometers, but as you increase your spend, Fluke products such as clamp meters, the 287 and 289 multimeters, and even other products such as iPads become available. So it's a pretty cool promo, especially if you were already planning on picking up some Fluke stuff, or really any test equipment in the back half of this year. Just wanted to mention that, and I'll have the details on that in my follow-up email to all registrants for this webinar. So appreciate you guys taking the time to hear that. Now, if you have any questions about the promotion or really any other Fluke products, please feel free to contact our Fluke sales specialist, Melissa Hill, at 800-828-1470. She's extension 3446, and the email address mhill@transcat.com. You can also contact Transcat at any time at 800-828-1470 or at sales@transcat.com. So we'll move into the Q&A session now. Just as a reminder, if you'd like to ask a question, please send it through the question box in the right of your webinar controls. I will also send out a recording of this webinar as well as the presentation slides. We get that question a lot, so I just wanted to state that up front. So let's see if we have any questions so far. Okay, I did have a question about the PowerPoint presentation. Yes, we will be, I'll send that out, and a link to it. It'll be on our SlideShare page, which is it's like a YouTube for PowerPoint presentations. Okay, so the first question I have is, we have a consultant that performs these alignments. Do we really need laser alignment tools as well?
That's a good question. Because of the high cost, and consultants are typically called in to just do the critical machines. But the problem is, what about the rest of the machines? And a lot of companies will just use consultants on just the 3 or 4 most critical machines, but there's hundreds of machines in the plant that are having failures, and seals and bearings are going. So we just can't afford today to have unplanned downtime and high maintenance cost and short machine life. So with a simple tool like the laser alignment tool, the Fluke 830, because it's simple and easy to use, then a technician can do the job, and we don't have to just call in a consultant to use the expert equipment. We can now use this to perform precision alignment on your own on the majority of your standard of machines. So instead of just reaping the benefits of precision laser alignment on a few critical machines, we can have all of our machines in our plant laser aligned, and the more machines that are running smoother, not only is your plant running better and production is up and costs are down, but also your energy savings are going to be much higher too.
Excellent, thank you. I have a similar question about using millwrights to perform alignments. Is there a difference there?
Oh, sure, yeah. So millwrights is kind of the same, but yet a little bit different, because the millwrights are going to be using dial indicators, and as we showed you earlier, the dial indicators they take a lot of time because they have complicated math and a lot of guesswork, and again, it takes an expert, and again, we're probably only performing these on critical machines. So because the Fluke 830 performs these calculations for you with a much higher resolution, you're able to get the answers much faster without having to have an expert, and that means that, again, your staff can be able to do more machines in your plant and save energy and time and make your machines run smoother.
Makes sense. Thank you. What else do we have here? Is this machine able to align a shaft to a bore? As an example, a rotatable shaft is misaligned with a stationary bore. No coupling.
Oh, no coupling. Probably not, because the purpose of the shaft alignment tool, at least the Fluke 830, is to cover the 80 or 90% of standard machines where you simply have a coupling and two shafts. And if you look about in a plant, most of your machines, there's hundreds and hundreds of these machines. But when we start looking at machines that are a little bit different and a little bit out of the scope of a standard machine, then you know, we quickly find out that so we can make using a standard machine, we can standardize the procedure, make it quick and easy. But if we start getting into machines that are a little bit more complicated, then we can't use a standard machine, and we're probably going to have to use a machine with a few more tools. So I'd probably have to look at the application, but from what I can hear, you probably wouldn't be able to do it with a standard laser shaft alignment tool. You'd probably need something with a little bit more advanced capabilities, and when you do that, then you're going to need a little bit more expertise and an expert to run it. So probably not.
Okay, great. And if the individual who asked that question would like to follow up or elaborate again, you know, we'll provide you that forum offline.
Right, because just, you know, sometimes when we see a picture of it or we have a better description, then sometimes we can say, oh yeah, well, even though we said we don't think we can, we might find out that there is a way to do it, but sometimes just off the cuff, if we can't think of it, we'd rather say, well, we're not sure, than to say, yeah, we can and we can't. So.
Right. Okay, what is the min to max range diameter shaft the laser can be mounted to? Interested mainly in the smallest size.
Pretty small. I don't know the numbers off the top of my head, but if you the determining factor is the chain, and that bracket chain. I've got a demo rig in my office where the diameter of the shaft is less than an inch, and I mean it's a little tiny shaft. So the chain can fit a very, very small shaft, and then I think it go up to like 17, 7 inches in diameter, and then we can get longer chains for even longer ones. So the answer to that question is the chain, and I think it's anything from like half an inch to like 10 inches. So pretty small and pretty big. We can get you the exact numbers. So we'll probably need somebody to give us a follow-up so we can get them the final answer on that, because I don't know it off the top of my head.
Okay. We'll take note of that. All right, I'll move on here. We do have a few more. We test seals by placing seals in a bore, and shaft is rotated internally with external hardware. We also do shaft rotation up to 30,000 RPM with a coupling type shaft to shaft. So that may have been a follow-up, actually.
Yeah, I'm not sure if there was a question in there. Yeah, I think that's a follow-up.
Okay. Okay, here we go. When attaching a motor to dyno, the motor shaft normally vary in size and not the same diameter. Is the tool able to accommodate this?
Yeah, the different sizes doesn't matter, because you're going to put a bracket on one shaft and a bracket on the other, or, I mean, you could mount them on the couplings either. So you can have a different diameter shaft on both ends. You could have a different diameter coupling, because, again, we're not measuring the coupling or shaft straightness. We're using a laser, and we're determining what the exact shaft center line is, and then rotating it around. So the calculation is all done by a movement of the shaft center line. So yeah, the brackets, the chain brackets would be able to accommodate for that just fine.
Okay, excellent. Is there a max RPM the tool will calculate tolerance for, such as a high-speed 50K RPM?
Well, tolerances, the first thing to mention about tolerances is there's tolerances that come from the OEM, which is probably the most important. And so we would always recommend that you would do your alignment to the OEM's tolerances. If you don't have the OEM's tolerances, then we would go to whatever the whatever the company's tolerances are. But quite often the user doesn't know the OEM tolerances or the company tolerances. So that's why built into the Fluke 830 are some industry standard tolerances, which are just based on doing laser alignment for 25 years or more, and what type of tolerances we see on typical rotating machines of that speed. So you can always, so I don't know the RPM ranges. I think we actually had a slide that showed that, and I can go to that slide real quick, but it looks like up to 7,200 RPM, and you'll notice from the table, as your speed increases, your tolerances are going to get smaller and smaller, so I don't know what the highest RPM would be, but these are standard machine RPMs that are built into the machine. The customer could always use their own tolerances as they see fit for higher speed machines.
Okay, excellent. Thank you. All right, looks like this is the last question, unless any more trickle in. We do have a few more minutes left. Is there a Fluke vibration meter that works better with the Fluke 830, example 805 or 810?
No, yes and no. The 805, which is the Fluke vibration meter, would basically tell you whether the machine is good or bad, while the 810, the vibration tester, would tell you what the exact fault is. So think of the meter as a screening device that basically would say, I've got a problem, you need further testing. I don't know what it is. It could be imbalance, it could be misalignment, could be bad bearings, but I just know there's something wrong. Where the 810 vibration tester would diagnose the fault and basically would say you have misalignment, and that misalignment is serious, and then you need to align the machine. So I think the best answer would be that for screening machines to know whether they're good or bad, the 805 is good enough. But if you really want to know whether you have a specific problem like misalignment, then the tester would give you a better answer. So since the question was what's the best tool to use for laser alignment, I'd probably say the tester, because it would actually tell you what your fault is, and then you would know that you need to do laser alignment, where with the 805, you don't know what the correction is, you just know there's a problem.
Okay, great. Okay, that looks like it. Did you have a question about whether we can provide training visits, demos, that sort of thing? The answer is typically yes. We do handle that on a case-by-case basis, but we do have a rental program and a training program as well. So looks like that is it in terms of questions. Well, actually, one more. I will get to this last one. What is the maximum distance between laser and mirror?
Oh, okay. The good news is that lasers travel over very large distances. So I would say at least 10 meters or 30 feet. So, you know, the number is probably much larger than that because lasers really go a long distance. So if you've got a machine that's anywhere near 10 meters between, you know, both sides of the coupling, you've got a pretty good sized machine. So I don't think that that machine distance is going to be a factor of aligning a machine with a laser alignment tool. Not a problem.
Awesome, thank you. So that's going to conclude the Q&A portion here. I'm going to wrap this up. If any more questions do trickle in, I will certainly have them answered either by John or somebody on our team offline, and we'll handle those individually. If you have any further questions or would like to find out more about Transcat's products or service offerings, you can contact us at 800-828-1470 or on the web at transcat.com. You can also email us at sales@transcat.com. I want to thank everybody for joining us today. We hope you found the information useful and applicable to your processes and jobs. Thank you very much and have a great week. Thanks, John.
Thank you, Jason. Take care.